One of the problems most students face at the beginning of calculus is finding difference quotients of trigonometric functions. And here I want to show you how to find the difference quotients of tan x. Basically, what we're going to be doing is we know our difference quotient already, which is f of x plus h minus f of x divided by h. And when we take the limit as h goes to 0, then we have the differential that we needed. So what we're going to be doing first is we're going to have to manipulate our trigonometry ratio. Without manipulation of trigonometry ratio, we actually will not be able to find the difference quotient, which will help us to find the differential that we actually require. We're using the fact that tan x is actually the ratio of sine x to cos x. So if tan x is the ratio of sine x to cos x, then let's get into it. I'm just going to substitute that right into the expression, and so we have this. I'm going to simplify this fraction, and this h right here, I'm going to make it to be 1 over h, and I'm going to simplify everything in this place. So we should have something of this nature. We should have limit as h goes to 0 of 1 over h, rather 1 over h. Let me just put a parenthesis here. So we'll have the LCM here is going to be cos x plus h, cos x plus h, everything multiplied by cos x. So if we do the basic fraction simplification, we're going to be having this. We're going to be having this sine x plus h multiplying cos x minus cos x plus h multiplying sine x. So that would then give us sine x plus h multiplied by cos x minus sine x then multiply by cos x plus h. So with this fraction now here's something we can notice here. Every time we are doing difference quotient that involves trigonometry, we are always going to be using all those things that we learn in our trigonometry. This is actually subtraction formula for sine of a minus b. So if you recall very well that sine of a minus b is equal to sine of a cos b minus sine of b cos a. So this is one of those trig identities that we've learned earlier, especially in pre-calculus. Now, let us look at this very well and compare it with this. Here, we can easily say that this x plus h right here is a, and this x right here is b. So if I do that, if I want to simplify everything here, that implies that x plus h and x, I will just substitute them as a and b here, and that will be x plus h minus x. So let's see what that would look like. So this would become limit as h goes to 0. We still have our 1 over h out here. So inside here we'll have x plus h, which is a, minus b, which is x. And everything is still divided by cos x plus h multiplied by cos x. So proceeding from here, we would have, of course, we know that this x would cancel out. So we have x minus x, that would be 0. We'll be left with h there. So I would just do this right here. So since I know that this and this goes, and I have sine h left here, I want to pair that with 1 over h here. So that would be sine h divided by h multiplied by 1 cosine of x plus h multiplied by cosine of x. Now the next thing I'm going to do is that I'm going to split this limit right here. So this is going to be limit as h goes to 0, that's for sine h over h, multiplied by limit as h goes to 0, and I have 1 divided by cosine of x plus h multiplied by cosine of x. So what happens is that if I take the limit of this separately, anytime you have limit as h goes to 0 of sine h over h, or even h over sine h, is a general limit which is always going to be 1. So as long as the variable is tending towards 0 and you have the ratio of sine and its argument, it's always going to be 1. So this is going to be 1. So you have 1 Now, if you take the limit on this other end, what happens is that h becomes 0 and you have cos x here. That will be cos x times cos x, and that will be cos squared x. So having this now, it is then going to be equals to the inverse of cosine is sec squared. So that will be sec squared x. And that is the derivative of tan x, which is sec squared x. And that's it. Don't forget to subscribe, like, and comment as well. If you also have any special math that you would like me to make a video on, you can drop it in the comments below and I will try to address them. I'll see you in the next one.